Chapter 12.5, Day 2, the area problem. Our goals are to use rectangles to approximate the areas of plane regions and use limits of summations to find areas of plane regions. The area problem. You now have the tools needed to solve the second basic problem of calculus, the area problem. The problem is to find the area of the region R bounded by the graph of a non-negative continuous function f, the x-axis, and the vertical lines x equals a and x equals, it should be b, shown in the figure on the right. And when the region R is a rectangle, triangle, or trapezoid, or semicircle, you can find its area using a geometric formula. For many other types of regions, however, you must use a different approach, one that involves a limit of a summation. The basic strategy is to use a collection of rectangles to equal width that approximate the region R, as illustrated in example 4. So we're going to use the 5 rectangles in the figure on the left to approximate the area of the region bounded by the graph of f of x equals 6 minus x squared, the x-axis, and the lines x equals 0 and x equals 2. So we're trying to find the area here. So we're going to use rectangles for that. So we notice that we go from 0 to 2, so we can figure out the width of each rectangle. And so just to kind of go over this once, we could figure out the right endpoints of each rectangle. Now we know that it's 0 to 2 and it's divided into 5 pieces. So really that tells us our width or our intervals. So it would go from 0 to 2/5. That would be from 2/5 to another 2/5 is 4/5. And then from 4/5 it would go to 6/5, right? You add another 2/5. And then add another 2/5, that would be, well, we'll start 6/5, and then it would go to 8/5. And then it would be 8/5 to 10/5 or 2. So the right endpoint of each interval is 2/5 times I, right? So I being interval 1, interval 2, interval 3, interval 4, and interval 5. So we need to find the sum of the areas of the 5 rectangles. Remember, rectangles, that's width times height. And so we are going to do this. The sum of the first 5 rectangles is going to be f of, and then this 2/5 I, that's our height. This is our height, times the width. And the width we know is 2/5. Right, so this is our width here. And so this f of 2/5 I, what's going to happen with that is we're going to plug it in to our equation here to find the heights at each of those rectangles. And so let's go ahead and plug that in. So it's 6 minus 2/5 I squared. That's f of 2/5 I. And then so this becomes 6 minus 4i squared over 25. So that is our height. So that's going to get substituted here. So this is going to be 6 minus 4i squared over 25, and then times the width of 2/5. So there are a couple ways to do this. So one way I'm going to do this is I'm going to go ahead and factor this 2/5 all the way to the front. So this 2/5, I'm going to multiply that to the entire thing at the end. And then times the 6 minus 4i squared over 25. Then we're going to split this up. So 2/5. And now this is going to be, so 6 will go here. The sum of I equals 1 to 5. And then that's to 1. And then we can factor everything but the I squared out. So this is going to be minus 4/25 of I squared. And then so now we're going to substitute using our summation formulas. So this 2/5 and then 6. And what that's going to change to is a constant. So that just becomes 6 times n. And then minus 4/25. And then I squared, we remember that as n times n plus 1 times 2n plus 1 over 6. Now we actually know what n is, right? It gives us a number. It gives us a number 5. So I'm going to go ahead and substitute that for each of these pieces in here. So that should be 5, 6 times 5. And then here, it's going to change that as well. This will be 5 as well. 5, and then 5, and 5. So let me rewrite that. 5, 5, and 5. And then now let's simplify this a little bit more. So this is going to be 2/5. 6 times 5 is 30. Minus 4, I'm going to leave that 4 over 25 times 5 times 5 plus 1 is 6 times 2 times 5 is 10 plus 1 is 11 all over 6. And then we just keep on simplifying, right? It's the algebra involved in this. So 2/5 times 30 minus 4. I'm going to reduce. So 5 goes into 25 5 times, and I can actually cancel out this 6 here. So now I'm looking at 4 times 11, which is 44 over 5. So then let's get a common denominator here in the inside. So 5 over 5. So this is going to be 2/5 times 5 times 3 is 150 minus 44 all over 5. So this is going to be 2/5 times 106 over 5. And then this will be, you multiply it together, so that's 212 over 25, which is approximately 8.48 square units. All right. So get to try one on your own. Now you don't necessarily need to write these here. You just need to know your interval on that. And so just try this example. It's from 0 to 2. You're looking at a linear equation. So f of x equals x plus 1 and the x-axis. So see if you can try this one out on your own. All right, so looking at this example, so you could have done it this way here, but at the end you would have 9 over 2 square units or 4.5 square units.